Today we are solving problem 3rd of IIT JAM 2025 exam. Two function f and g are given and we have to check the differentiability of both the function at x equals to 0. So to check the differentiability at x equals to 0, we have to check for 0 plus h minus f of 0 by h, this limit. If this limit exists, then the function is differentiable at 0, otherwise not. So let's substitute the function f. We'll get limit h equals to 0, h tends to 0. This is h mod h modulus of sine 1 by h. Cancel out, f of 0 is 0. Now we know that mod of sine of 1 by h is bounded in between 0 and 1. So this whole numerator will be bounded in between 0 and mod h. And as h tends to 0, right hand also tends to 0. Therefore, it has been sandwiched between 0 and 0. Thus, the numerator limit is 0. Hence, the limit exists and f is differentiable at 0. So, f is differentiable at 0. Now, we repeat the same thing for the function g. So, instead of f, let's substitute g. So, we'll get h square sine 1 by h plus h cos 1 by h divided by h. So this h will cancel out and 1 power will cancel out. Now, we know there is a hint to this. If you see the function of cos 1 by h around 0, it will be like oscillating around in between minus 1 and 1. Similarly for sine 1 by h, but sine 1 by h is multiplied with h, so the oscillation starts to like get small and tends towards 0. So that's not a problem. So we know that the problematic part is the second term. To show that, let's consider a sequence hn of, we know that at pi by 2, at odd multiples of pi by 2, cos is 0. So at the multiples of pi, sine is 0, so cos will be 1. So we have to take multiples of pi. So n pi, you will take hn to be 1 by n pi. Then your left term will be 0 at these points, and your right term will give you 1 minus 1 and so on. It oscillates between 1 and minus 1. Hence, the limit does not exist and g is not differentiable at 0. Therefore, our option A is correct. If you have any doubts in this, you can comment down. I can solve the doubts for you.